Just want to give some announcements on the format that we're going to be doing today. Again, thank you for all attending the Full Spectrum series. We're going to continue to be doing this for the next few months to highlight all of the majors in the Hajem School and also material science and data science. So we're looking to be able to have not just students who are seeking, potentially a different path at the university. Also, prospective students might want to get a little more introduction on each of the majors and the university community, because we want the university community to be able to see what the good things that are going on all this time. The fact that we're still going and having a very productive semester despite all the constraints. I'm going to ask a request in a moment. If you want to put your email in the chat, I'll prompt you to send an email in the chat just to see if you can be eligible for any of the prizes that we can potentially give away. We're trying to do this every week to give away prizes for those who participate. That also applies to students who are doing this asynchronously. I'm going to put my email address in there so you can send me your information because we really like that you'll be able to attend and also potentially get something physical out of this. So today we have computer science with Dr. Adam Purtee. Dr. Purtee has been very gracious with his time, both to do this for us now and at previous times over the summer for our incoming students in the Early Connections Opportunity Program. So I'm going to turn this over. If you have questions, feel free to say them. I'm also going to be monitoring the chat to help Dr. Purtee be able to manage both of those at the same time. So I'll turn it over to you.
Cool, thanks, Nick. So yeah, hi everybody. My name is Adam Purtee. This is sort of the second time I've given this short talk. So kind of what I'd like to do is give you an overview of the computer science program and try and give you a little bit of the context. And then if people have any questions, I'm happy to take them at the end. So I do have a short sort of PowerPoint. Let me set that up. Okay, so if you want to get in touch with me, best way is probably to send me an email. My address is on the screen. It's just apurtee@cs.rochester.edu. And then if you want to know more, of course, I've got a faculty page too. So I can go ahead and get started and tell you a little bit about who I am. So I am a member of the instructional faculty in the CS department, which means that my full-time job is teaching. So along those lines, I'm currently teaching 3 courses. I'll tell you a little bit about that in a moment. But kind of regardless of which course you're in, I have the same general purpose goals. I strive to give detailed technical lectures with interesting demos. I can tell you from very recent experience that this has been a little bit challenging with synchronous versus asynchronous courses. So I'm teaching 2 hybrid and 1 fully remote. So this is still my goal, but sometimes it's a little bit difficult to convey technical details over Zoom. So there's a little bit more reading this term than usual. But I think it's working out. So along those lines, I also like to provide students opportunities for practice and self-study. Basically, this is always true, but especially now, if you are going to college, you are in a unique opportunity to kind of change the direction of your future life. And many people take full advantage of that. So I view, in addition to giving you lectures, part of my role is I like to try and give opportunities for you to sort of work outside of class. I guess that's another word for homework, but that's kind of how I approach homework. And then lastly, I try to assess student performance as accurately as possible. So that means things like, exams, projects, and grades. And my goal is sort of twofold. I want to be able to assign final grades, so I try to do it as uniformly as possible. But also, I view grades as a useful signal from the instructor to the student. So whenever I take points off, it's not meant to be like, like a mean thing or intense. It's meant to be a signal to a student, hey, maybe you should get some more practice in this area. So that's kind of my general teaching philosophy in 3 bullet points. Of course, we could talk about that all day, but maybe we should talk about some computer science. So my specific experience in teaching includes, so I taught Intro to Programming at teach it here now in Java. I've taught it at RIT in Python. I've taught some AI classes. I currently and have taught computer networks, C programming, and computer vision. So kind of a mixture of hardcore programming classes and then more mathy AI style classes. So my interests are basically the intersection of those things. I'm really interested in numerical programming and simulations, basically anything that uses intense computer hardware and makes the fans go. That gets me excited. And then also things like computer security and privacy and the internet, which is really interesting now. For instance, the fact that we're not having this conversation together in a room, we're having it distributed over the internet. And so, who knows is actually participating. But anyway, so kind of along the lines of my third bullet point, I also do a lot of AI things, especially with neural networks and natural language data and common sense reasoning. So part of the reason I like to be a member of the instructional faculty is it gives me an opportunity simultaneously, and I get to meet students and kind of convey some of the fun parts of all this stuff. So cool. So it's my understanding that the audience, the sort of target audience, is students who are enrolled at U of R, probably, or who are maybe considering it and watching this in video form. And you're interested in pursuing a degree in computer science, but maybe you don't know how to do that or what it's about. So there's a few entry points to our program. Basically, if you're of no previous experience and you're completely new to computer science, like never programmed at all, or you're just kind of not sure about the field and want to check it out, the course CSC 161 may be for you. So it's kind of an intro to programming and Python, and it's, there are no prerequisites. If you have some exposure to programming, or if you just know that you definitely want to do this and you want to kind of jump into the deep end of the pool, you'll sign up for CSC 171. So that's the class that I'm currently teaching. And as I mentioned at the beginning of the call, we're currently having our first asynchronous quiz, which is kind of an interesting experience. Anyway, if you are further along the spectrum and you maybe have taken some classes in high school, or you have some serious projects and things like that you've worked on, and you think 171 might not be enough, there is an opportunity to skip it. So once a year, we do a CS placement exam for incoming freshmen. And of course, if you have AP credit, you can skip it. In those cases, you'll take 172, which is data structures. So by far, most people, when they do computer science, their first course will be 171, probably in the fall, and then 172 in the spring, or maybe shifted depending on when they decide they're interested. So there's a few people live at the moment. Let me just pause. Does anybody have any questions in terms of like the entry point? Seemed pretty tame. I'm not sure how many actual students are connected.
We have about 7 students, I believe, that are connected right now. 7 or 8,
Okay.
I believe.
Cool. Okay, well, I'm going to assume that means everybody's good, so I'm going to go ahead and move on. If you change your mind, have questions, as Nick mentioned earlier, put them in chat, and I'll try to pause and address them. So, degrees in CS. Basically, there's a couple of stages that you get through. The first is you have to satisfy what are called the PreMajor requirements. So this is where you have 171, which is the class I teach, 172, which is taught by different faculty. I think right now it's Professor Erasrat Jupa. And then you need some math. So discrete math and calculus. Once you've done all of that, and I think it's C- or above, so you got to pass the classes. Once you do all that, you can officially declare yourself to be a computer science major. Your next objective is to complete the core courses. So these are the 6 most core fundamental courses that we offer in the computer science department. Everybody that does a BS degree has to take them so that our graduates sort of have a fundamental skill set in common. So in addition to the core courses, you've got to take some advanced courses too. So this is 4 upper level classes of your choice. And this is normally where people mix in their kind of funky electives, things on computer security or computational complexity, deep learning, computer vision, things like that. This is where most people take their special topics classes. So as with, I think, all other degree programs here at U of R, there's some other stuff that you've got to do to become, a well-rounded, broadly educated person. And that includes some writing requirements and some cluster requirements. So for computer science, we require you to complete a cluster in humanities and a cluster in social sciences. So if you want to know the full story, of course, go to our website. It's at cs.rochester.edu, and you can find a description of the undergraduate program degree. So just about computer science, it's kind of difficult to explain exactly what it is sometimes. Some people kind of have the impression that computer science is just writing programs or things like that. That's not really true. It's more than that. So I tried to write my own definition of computer science. So this is what I came up with. It's really a study of the limits of computation and design of new computing systems, and then developments of solutions to problems. So all three components are really important here. So the limits of computation from the purpose of computer science are not about what can we do today. It's more about developing mathematical models that say, what could we do with the most perfect, powerful computers you could imagine? And then in the second point, again, we're not just concerned with how do you make the best use of computer systems now, but how do you build new stuff? So there's been, of course, huge revolutions in computing power over the past decades, starting with the transistor in like the 1950s. But even recently, the definition of computing is changing with things like cloud computing and deep learning occurring on huge clusters of graphical or GPUs. So exactly what is a computer? That definition is even still changing. And then lastly, if I had to say that there was one core domain of computer science, I would say it's this third. So now, there's a really cool quote here from Dijkstra, maybe. It's one of those apocryphal quotes that nobody's really sure who said it first, but I like it. Computer science is no more about computers than astronomy is about telescopes. And if you're not feeling too good about that, because you might think, well, astronomy, we use a lot of telescopes. Well, you use a telescope to see planets and stars and nebulas and things. We want to know, we want to know what are the limits of computation and what can we do in the future. So, philosophical waxing aside, let's talk specifics about the CS program. So I'm going to talk about the Bachelor of Science program. We have a couple others. This is probably like your most standard CS undergrad degree. And it has the requirements that I mentioned before. So that's the PreMajor Requirements, core, some math, some advanced stuff, and electives. So I've already kind of touched on the PreMajor Requirements. So I'm just going to go ahead and move on from that and talk about our core courses. So there's 6 here. They're all, in my opinion, awesome. You are very fortunate to have the opportunity to take these courses from the instructors who teach them. So 173 will be your first introduction to the real sort of the cool math that tells you what's possible in certain limits. So that's where you really learn about Turing machines and finite automata and things like that. That sets the stage for all kinds of stuff in your future career. 242 is Introduction to AI. That's in 1 semester. You get to see some of the classic algorithms of AI all the way back to search and constraint satisfaction, up to some more recent things like Bayesian networks and backpropagation and things like that. So that's a great course as well. For computer organization, this is your first hardcore systems class. What I mean by that is now you're talking specifically about physical hardware. You're talking about processors and memory and buses and bandwidth and latency and caches and all other kinds of cool stuff. That's when you'll start learning how to write code in assembly language, which is even deeper than C and Java. So going deep into the machine with 252, we have another course on what can you do with programming languages. So that's CS 254. Now, to give you an idea of what goes on there, in Introduction to CS, the class I'm teaching, we spend the whole semester learning Java. You don't learn all of Java, but you will learn a lot of it. In 254, you cover multiple programming languages, but there, your objective is not to become deeply practiced in each individual language, but instead to see the patterns, to see the entire big picture. So you approach each language, programming language, much like a linguist would approach human languages. And you see what they have in common and where they're different, and where some things are easier in one language than another. And that's where you also have discussions about, how do I make a new language? I want to build a new programming language that allows me to solve harder problems with less work. So going down the list at 280, you're going to come back to that thread of the theory of computation that you started back in 173. That's when you're going to push even farther into the underlying mathematics of computation. And you'll see things like the halting problem and complexity theory. And lastly, with 282 as an analysis of efficient algorithms. If you will allow me to be a little bit cheap of algorithms, almost like spells or conjurations, if you play video games or like fantasy novels, things like that. In 282 is when you have enough background in the rest of computing that now you can see the really fine details, and you can learn some powerful, important techniques that will allow you to set yourself apart from others in the field. So all of these courses are challenging, but it's well worth it because you learn a huge amount about fundamental computer science. So once you get through that, now you have choices. So if you're doing a BS degree in computer science, you got to do all the core classes, and then you get 4 more advanced courses. That's where I'm kind of looping back and talking about basically your special topics. So I just pulled some up. It's coming later. So I pulled some classes up on a slide in a few slides coming forward, and I'll kind of give you some examples. But here at U of R, in the CS department, we can kind of break things down into a few broad areas. So those areas are systems, which are theory, AI, and human-computer interaction. Each one of these 4 groups has a sort of subgroup of CS faculty and programming language from before. So it's a full description, but we've already kind of talked about them, so I'm just going to connect them back to the core classes. Theory of computation, those are the first and last course, where we're talking about computational models, and limits of computation, and things like that. So that's when you learn the tools to understand how to make programs really fast, or how to recognize problems that are sometimes mathematically unsolvable. So theory is more of like the mathematical side of CS. So another broad area, which is, if I had to pick a label, this is where I would fall, is artificial intelligence. Artificial intelligence has been super exciting over the past several years. It seems like every day, well, that's exaggerating a little bit, every other week, there's some crazy new thing that's been invented in the field of AI. One of the most powerful driving factors right now is deep learning and our ability to extract patterns from huge, vast amounts of data. The other reason that's happening is because now, for the first time in sort of the history of the world, we have huge amounts of digital data. So this combination of massive increases in computational power, algorithmic advances from the field of AI, and huge amounts of data has allowed the field of AI to really push out to new frontiers. So very exciting stuff. So our fourth kind of group that is worked on in U of R is human-computer interaction. So this one is kind of a blend of multiple regions. HCI tends to focus on applications that really sort of impact people's lives and improve them in a personal way. So this is things like accessibility and social skills training and other stuff on those lines. So the human-computer interaction programs tend to pull from multiple bags of tricks. They need AI so that they can do pattern matching and interact with language, voice, and vision. And then they need systems because the tools, if they're working with real people, they've got to run on real hardware and it's got to be efficient, otherwise it's not going to work out. And lastly, theory, again, guides the way. It helps you know when you're coming up against a brick wall of complexity, and instead of going forward, you've got to find a way around. Altogether, there's a lot of different things going on in the CS department here at U of R, and it's a huge field with lots of opportunity to kind of distinguish yourself and choose your own path. So as I mentioned, I wanted to kind of loop back to some advanced courses. This is just stuff I've pulled off of CDCS over the past year. We've got everything from machine learning, advanced computer architecture, cool collaborative programming techniques, brand new languages, parallel systems, cryptography, deeper math in theory, lots and lots of choices. And this is pretty much constantly changing. What happens is a lot of times research faculty will teach a special topic on just their research area, and then bam, there's your advanced course. So kind of tying it all back together, we've got the pre-major requirements, the core classes, then it's a choose your own adventure, pick some advanced classes, and make sure that you round out your education with humanities, social sciences clusters, and writing, and of course some electives. So there are other programs here in the CS department. We have a Bachelor of Arts degree, which is similar to the Bachelor of Science, but the requirements are lesser. I'm not super familiar with that. If you want to go in the other direction, there is an honors program where you can do additional work. And those of you who are committed to another field, but you want to get a little bit of CS experience to sort of bulk up your stats, we offer a minor as well. So again, looping back, for the full story, all of this is available on our course page. The information is regularly updated, and it's your best source to kind of jump in. At that, I'm going to go ahead and stop because I kind of give you an overview and see if anybody has any questions.
I'll ask just kind of a quick question here. And can you, the boundaries between what's computer science and what's not computer science, they get more and more blurred, right? So how would I decide, hey, I want to be a computer scientist as opposed to a data scientist, or as opposed to, I mean, you mentioned the astronomy application, right? So I want to do astronomy, but maybe if I want to do astronomy, maybe I should really be doing computer science in order to analyze the data. Can you kind of, how would you make that cut?
So that's a super good question. Probably any answer that I really committed to, people would disagree with me. So I will say that there's lots of blurred boundaries, and it kind of depends on what your focus is. I will be a little, I don't know what the adjective is to describe my intentions here. I don't know if it's brave or foolish, but I'll say that as a computer science person, if you get a computer science degree, you can then sort of pick up a second field and you will have vastly more computational tools to bring to bear on the problem. But same thing kind of makes sense, right? Like if you wanted to work on, say, excuse me, computational astronomy because you want to analyze the huge amount of data that we have now and look for exoplanets, well, you really need to know both. So I would say in the real world, we need specialists in both areas. And whatever you're more passionate about, I would probably recommend that as a primary major. But I will say among almost all academic majors, and again, I don't know if this is brave or foolish, computer science offers students more flexibility than most.
Is the path you sort of outlined, hinted at, of doing a computer science degree and then maybe a master's in something else, or the inverse, doing a bachelor's in chemical engineering and then doing a master's in computer science? Is that pretty common? Is that?
That's another great question. So I just happened to have, this is my second year here. I just so happened to be on the master's admissions committee, so I've kind of been looking at a lot of these applications. So it depends. So if you don't have any computational training, it's going to be pretty tough to jump into a CS master's program, because basically you kind of need that core, the core fundamentals in order to make progress. But I would say somebody who had, let's say, chemical engineering as their primary degree, but maybe they minored in CS, I would expect that they would have a very strong ability to jump into a CS master's program, because they're both like really technical fields. So there is some overlap, and I think also a lot of courses, a lot of fields now use CS stuff at the very sort of lowest level. Maybe you're just using Excel spreadsheets to do some analysis. But more interestingly, people are using packages like MATLAB and R, et cetera, which kind of ties in a computational nature sort of across fields. So I'd say you could go either way. But if you really want to be a chemical engineer, I think that's what you should study first.
Another question, two other questions. Most of the courses you listed have numbers in the 200s. How do you know what sequence is best?
So that I would say would be a good conversation to have with your faculty advisor, because they can kind of give you a more nuanced description about the actual sort of electives and where you want to go in terms of your advanced classes. I will say on that slide, I mentioned sort of advanced courses. I wasn't being super careful. There are probably some courses on there that are not like upper level enough. So that's not an authoritative list. That's literally me just looking up as many CS courses as I could find. So for the real story is you should connect with your faculty advisor, who can coordinate and with the other faculty members and let you know.
And the next question is, as a prospective student, is the CS major accredited by ABET, and is that an important accreditation for CS?
I really don't know. I can find out for you. I think so, but I don't know.
I can jump in here. And the fact that you don't know is going to be part of my answer, right? Our CS program is not accredited. Our engineering programs are. And I think that's probably, it's not because we don't think the CS program could be accredited. It's just we don't think the CS the accreditation is as essential. And I think you'll find that if you go out and look around, most places that's the case. It's really critical for your engineering program to be accredited, but generally CS is not. It's not considered to be critical. And I'm going to follow up. I see there's a follow-up question, which is, what is ABET? ABET is the national body which accredits things like engineering and also some CS programs, cybersecurity, some programs like that. So ABET is the main accrediting body that we work with.
Thanks, Paul.
Another one is, can you clarify the difference between AI and human-computer interaction?
I can try. So I would say that AI is more focused on building the tools and as far as their intersection goes. AI is focused on building the tools, and human computer interaction is focused on using those tools to make people's lives better. So AI kind of is more neutral in the terms of how these things are actually applied and used. We're more focused on algorithms and math and kind of like what's possible, whereas human computer action, there's more of a focus on the actual sort of human experience. There's also plenty of HCI applications that are sort of constructed out of intuition and skill and practice. So not every HCI experience is AI. HCI and AI intersect, but neither one subsumes the other.
All the questions. Does anyone have any more questions? Yes. Okay, a couple more coming in. What makes computer science quote unquote challenging, and how is it different from computer engineering and data science?
Okay. So again, computer science guy, not data science, not computer engineering. So my understanding of computer engineering is it's more closely related to electrical engineering. So computer engineering intersects with computer science through the systems field. So computer engineering is where you say, okay, how am I going to build this circuit that builds a cache memory that has a certain latency? Like, oh, if we use this different construction methodology, we get, better performance. It's a little outside my domain, so I can't say too much other than to say it's more focused on how do you actually physically build this stuff. So data science is almost in the exact opposite direction. So whereas computer engineering is how do we build things from the ground up, data science is more focused on how do we use the tools of AI and some other stuff, mostly statistics, how do we use that to solve problems? So data science, I view it as again sort of more of an application oriented field. If faculty from data science may thoroughly disagree with me, in which case please reach out and educate me on that subject. But that's kind of my understanding of how the things relate.
Let me just real quickly jump in to say that we have a data science presentation which will be coming up as part of the series here, the FSS series. So if you're interested in data science and computer science both, you might want to stop into the data science presentation as well. Also, our electrical engineering department is actually electrical and computer engineering. So Adam is right on target in terms of the relationship between computer and electrical engineering. And they will also have a presentation as part of this series. So again, if you're interested in that as another possibility, I would encourage you to come to that presentation as well.
That sounds like a great suggestion. In terms of the intersection, this is a little cheesy, but since it's remote, we can do show and tell. I'm a computer scientist. I'm not really great with hardware, but I have a lot of fun messing around with it. So like I have an oscilloscope and power supply and function generator and all this other funky stuff. So like that's the stuff that I want to do whenever I have free time. It's just been a very long time since I've had any free
time. We got more questions. Can computer engineering and SC be combined as a major?
What is SC?
CS. You mean CS?
Oh, CS. Oh, God. So CS. I see it now.
Computer engineering and computer science, I think is the question.
Yeah, I think so.
I'm pretty sure that programs are flexible enough that you could major in both, but I don't have enough experience with computer engineering to really answer authoritatively. I know from a faculty perspective, I have lots of students who are doing double majors in all sorts of different things, and I'm almost positive it's possible, but you need to touch base with someone from computer engineering to make that a certainty.
I could say through advising, what happens the most is that students will find out what camp they're in after a semester or two. It's a little easier to start off in ECE, electrical computer engineering, and then change to computer engineering only because the math that you have to take and when. So if you want to take the introductory CSE 171 class, you could take Math 150, and they're both offered every semester. So that's one of the things that we talk about a lot with advising in both college advisors and faculty advisors for this.
Yeah, and I would just add
Okay.
that doubling with ECE and CS is pretty difficult because of the rigidity of the ECE schedule and the sequencing. But we do suggest students try out both majors their first year, whether it's first semester or throughout that year. And ultimately, students typically choose one of those programs as their major and then the other as a minor. And that's definitely doable. And they definitely complement each other well.
And also, that's Sarah Klinkbiel, who is
Hi,
the undergrad coordinator from CS, who knows everything about the programs. We have another question. What course addresses the ethical issues and behavioral issues related to how you build software?
So that's a good question. I think there is at least one course. I think it's called Social and Ethical Implications of Computing, I think, but I'm not really sure. I don't know much about that offering, but I know it's on a lot of people's radar as a subject that's becoming increasingly important. So I know there's at least one course you can take that's offered on a regular basis. And speaking completely unauthoritatively, I expect that there will be probably more offerings in that domain in the future. But again, this is just completely just my personal opinion, that it's not based on anything from anybody.
So, Sarah again. We do have CSC 299, which is social implications of computing, and that is offered each semester. The philosophy department also offers different courses related to bias in computing, and they go way more into any bias found in algorithms and all that fun CS stuff.
Thank you. I'm glad. I almost suggested, there was another, when people were asking about some questions, I almost said an email, Sarah, but I didn't want to send too many emails your way.
Yeah, no, I was watching from afar.
Do we have any more questions?
If not, I've got, or people are thinking, I've got two more items here to attend to. I don't know if I actually introduced myself. So I'm Paul Funkenbush. I'm the Associate Dean in the Hayden School. I'm here in the Deanery in the Lattimore building. One thing we want to do is make, again, those of you who are here live, as well as those of you who watch synchronously, the CS department has donated a bunch of interesting swag for you. So we have some drink bottles. We have, I don't know what this does, but I've seen them around in the computer science desk. I don't want to open it, but if it's interesting little Android marker. We have some pop discs, some stickers. We'd like to give those out to people. So if you would send Nick your contact information, we will choose winners from among those who send in the contact information. And we can either send that to you, or you can come directly here to the Deanery and pick it up from me live. So we have all kinds of swag from all the different departments in the Deanery here. So feel free to participate and try to get some of that swag if you want. Also, I want to introduce Laura Jones, and I see David is here as well, David Kuda-Buchholz from the Green Center. So one of the things we're trying to do with the Full Spectrum series is make people aware of the options or the different majors which are available. And the Green Center is a great resource for our students here. One of the things they can do is help you find a major, help you kind of navigate among the majors. So Laura, do you want to just say a few words here, or David?
Sure, yeah. So absolutely, as you are exploring careers in computer science or anything, if you want to see how you can combine your interests with computer science, I encourage you to make an appointment with an advisor at the Green Center, and we'd be happy to sort of explore these things with you. Of course, you would do that in conjunction with, you know, your academic advisor, your faculty. Really, it's all about being curious and trying stuff out and talking to people. And there are more people you can talk to, such as alumni. And we have the Melia Collective. You can find more information about that on our website. There's also LinkedIn. We can help you navigate that site as well. When it comes time to building resumes and writing cover letters and all that good stuff, we can help you do that. So please make use of our office. Our website is rochester.edu/career center. And one question that I get a lot is, can first year computer science students get internships? The answer is yes. So come see us. And that's what I got for you.
Thank you, Laura. Any last questions? No?
In the chat, David has put the about the Melia Collective too. So if you get the opportunity, please visit that. I'm also going to highlight it so when we post the video that the students can access it without seeing the chat if they're asynchronous. Any other questions? All right. Well, Dr. Purtee, thank you for coming in and giving this presentation. We're really happy that it's able to reach so many different people who are trying to figure out their starting point within CS. So as you can see, for those students, especially the prospective ones, you have several points of advice. You'll have college advisors, faculty advisors, advisors from the Green Career Center, undergraduate coordinator. So we have a lot of contact points. So if you have any questions, we're all, you can also look us up too. We'll put our contact information here, but you can look us up via the directory through the UR site. So if there's nothing else, again, we're going to go out into the world and do our best. And thank you all for attending. And we hope to see you on Friday at 2 o'clock for chemical engineering with Dr. Mark Porisoff. Thank you.
Thank you for coming, everyone.